Right, so firstly, why the ACQ580? I mean, firstly, the ACQ580 is designed around the water industry. So it's got specialized software to cater for all the different needs, watering needs. For instance, if you're suffering from pipe hammering mode, or you've got, it's got multi pump mode. It's got all those features that James is going to go over. Then another nice thing about for these drives is as well is the different frame sizes. We go from IP20 to IP55, so it caters for all the different kind of industries, from where you install it into a substation where it's clean, from mounting the drive next to the motor in a very dusty environment. Okay, then the smart embedded functions. Okay, that's, for instance, as I said, that's like software that we'll actually look into. Effortless commissioning and configuration, very easy to program. I mean, everything is, it's got, a lot of them have got wizards. So you basically follow it step by step and you can set it up. So it is very, very easy to set up. I remember in the old days, you used to have just codes on the drives and you had to basically walk around with a manual and look and see what is BE02, DE02, etc. No longer. That was like the old MS-DOS 6.22. Now we, all up to scratch with the Windows platforms, etc. Right. Let's go. Okay. Now, first of all, the different drives. Of course, is the ACQ580 which is your wall mount unit. Let me try and see if I can get my pointer working here. So this is your wall mount unit, which is from a 0.75 to a 250 kilowatt. That's available, which is basically all to do with if you want to mount it on a wall or you want to mount it in a substation, you're going to be going with those. But as I said, the limitation is 250 kilowatts. And then we have the ACQ580 which is the modular unit. Can you guys all see my laser pointer? Is it working?
Yes, it is.
All right. So this is, of course, your modular unit, which is specifically designed for if it's in existing panels, if an existing panel that you want to put in, or you want to perhaps make the offering to a local panel builder, then this is easier way to go. Right, then we've got the ACQ580 which is the cabinet unit, which is, there you don't need to have like an existing, anyone to build the panels, etc. This is, you can order it with start-stop buttons. You can have amp meter, volt meter, everything built onto it. It is a more expensive option, but nevertheless it is also available. Then we get to the ACQ580 which is the low harmonic wall mount drive, which I'll basically go into more depth in the next couple of slides. Then we got the ACQ580 which is also the low harmonic drive, but it's the modular unit. Right. Next, here is a breakdown again of what I've shortly mentioned. The wall mounts is from 0.75 to 250 kilowatt. You have a variety, well, you can either choose IP21 or IP55. Then we've got our drive modules, which is from a 250 to 500 kilowatt, which is basically like the one over there, these modular units. We've got the cabinet drives, which is available from a 75 to a 500 kilowatt. And then we've got 3 IP ratings that are possible, IP21, 42, and 54. Then we've got the low harmonic drives as well, which is the modular unit, and we've also got the cabinet units. Okay, now when we look at the wall mount units, okay, there basically we have all the different frame sizes. From a 0.75 up to a 250 kilowatt, there you can actually see. And we've got, so in total, we've got 9 frame sizes. And of course, the voltage limitations are 200 to 240 volts and 380 to 480 volts. We don't have a 525 to 690 volt available in this range. That would, of course, then be moving over to the ACS 880. And with the ACQ580s, the warranty, standard warranty is 36 months with the ACQ580s. Okay, mounting alternatives, either IP21, 55 or flange mount. IP21 would be if you're going to be installing this into a cabinet, MCC, or if it's in a very clean environment. Even you can actually mount these on the wall if it's in a clean MCC. IP55 would be if it's in a very dusty environment, or perhaps if you want the customer wants to mount this close to the motor, but you don't have an MCC to mount it in, then you can go with IP55. Now, when you look at the differences, you'll see that the IP21, okay, I'll show you just now because it's not very clear to see, but the IP55 has got a plastic cover over it, and it's also fully enclosed. If you look at the IP21 on the side, you've got those vents that are open. With the IP55, it's a fully enclosed casing. So that's basically the difference. So it's, for instance, here you'll still get a bit of dust and ingress coming in there, and here you won't. And then we've also got a flange mount unit as well, of flange mounting. What basically happens here on the front of the drive, it's at IP21. So the controls, etc., would be IP21, and that would be IP55. Now, a scenario where you would actually install this is if it's, say, for instance, in a container or something to that effect, that would be actually the wall, and that would be the outside. So the heat and all that kind of stuff will actually just, it won't go back into the substation. It'll basically take place outside. And then the IP21, of course, if it's in a very clean environment substation, IP21 is more than sufficient. So those are also available as well for ordering. Right, and then you can also order these drives as well with a, if you want, you can have it with a main switch option, which is shown over here, and also with a integrated MCC1 filter as well. Those are also options. Right, and then other options available. Okay, most of the time when you're going to be mounting these drives into a panel, you'll always need one of these, a remote panel kit or a control panel door mounting kit. Okay, so that'll basically allow you to put the display directly onto the actual bracket, and this bracket will basically be on the panel, the panel door. So if you've got a big MCC, that'll be on the panel door, because what happens in the past, and I've seen it before as well, and a lot of you guys will agree, that what happens is if you don't have that, and say for instance on site, the guys want to see if the drive is tripped or they want to change something, they actually open up the panel door. And sometimes what happens is, okay, they'll make the changes, they'll see if the drive's tripping, and the panel door doesn't always get closed. It might be slightly open, etc., and then you'll get all this dust, etc., floating into the panel, and then you'll start getting issues like your fans clogging up, etc. So if you have this door mounting kit, that just makes it a lot easier. You don't have to open up the panel to see if the drive is running, if it's stripped, etc. So that's quite essential. Then you've also got different cards, I/O cards. If you want extra input and outputs or extra relays, you can actually order an additional card. And you've also got the communication cards as well that are available. Right, then we get to the modular unit here. Of course, as I said, this is more for a scenario where this is going to be going into an existing panel or a new panel. That goes from a 250 to a 500 kilowatt. And there, to move it around, it's actually got wheels at the bottom. So it's quite easy to move it around. And there it's got those little ramps. So if you need to get that into a panel, you can basically clip that onto the actual bottom of the panel, and you can roll this into the MCC. All right, and if you go for that option, the control panel and door mounting kit are actually included, because I mean you do need it. And the ratings, IP ratings available are IP00 and IP21, or sorry, IP20s. Mike, how's my pace? Am I going okay? Am I going too quick? Are you guys all okay there?
I think you're all right. If you're going too fast, we'll get some comments in the chat.
Yeah, please, guys.
And I'll let you know.
Yeah, please tell me if I am. Sometimes it sounds like I'm trying to catch my bus or whatever, but yeah, sometimes I do get carried away.
Thanks, Vince.
Right. There's also some options that you can basically order as well for the modular units, the finger guard kits, which is basically to cover that. There you've got the I/O options. So you have also a couple of other options that you can order as well. But what we'll do is we will make sure that we'll attach some literature, the catalogs, etc., to this actual training session. But also what you guys could do is, I think I have told you guys in the past, if you have missed it, there is something called the ABB drive library, which you can download onto your mobile. So if you do need to access any catalogs or manuals or anything like that, you guys can easily access it, and it is also the latest material as well. So if you haven't downloaded yet, then maybe just do that, and then you'll see it's quite easy to use. Right, then we've got the cabinet units. Okay, there you can see it's a cabinet on its own. When you open it up, okay, there you'll see the control cards. It's got the relays. It's got everything built in. You can even basically order it if you want with cabinet lights or amp meter, voltmeters. Yeah, you've got your start-stop buttons. You've got your switch buttons, and then you've got your status buttons, your on and off, your fault, your running button. You've got a mains isolator. So there's a lot of different things you can order with this. And in total, there are 3 different frame sizes. There's actually more. There's R6 to the R11. So those are the ones, 75 to 110 kilowatt. That is basically 400 mil cabinets, then a 500 mil and an 800 mil. And the IP ratings available are IP21, 42, and 54. Right, then there's the cooling arrangements for the VSD as well. So the normal thing is, okay, you've got the cool air coming from the bottom, then it basically pushes it up, and then hot air gets pushed out at the top. So it's a normal kind of setup there. You've got the hot air and the hot air as well that will escape into the substation. That's always very critical, that where you install it, you should always have the appropriate cooling, air conditioning, etc. Right, the low harmonic drives look exactly the same. Well, more or less, no. They might be slightly bigger. You'll see in the cabinet, in the modular unit, that it is actually wider, the same with the cabinet as well. The reason for that is because now it's actually got the built-in filters. The filters are basically included in the drive contactors or contactors. So everything is built into the drive. It is a more expensive solution, but a lot of days, a lot of times the low harmonics does pitch its head, and that's a different monster on its own. So if it is a scenario, for instance, I'll give you an example. Let's say, for instance, these drives are going into like a hospital where there's a lot of sensitive equipment, or maybe these drives are going, going to be hooked up via generator, etc. Then a low harmonic drive is a good option. But as I said, it is going to be a more expensive option. Nevertheless, it is available. Okay, then we've got the low harmonic modular. There you can see it is slightly wider because there's, as we said, the filters are actually included. Because sometimes it all depends. You've got to look at, for instance, your cable distances. That's one thing that we always ask as well. What is the cable distance like from the drive to the motor? If it is quite a long distance, then we need to start looking at the likes of DU/DT filter, sine wave filter. So those are always things that we need to keep in mind. All right, and then the hardware side of it, these are your control units. So in other words, this is your control card, and then you've got all the different terminals. That is basically exactly the same. Well, it does exactly the same, the control card, except it's for a different frame size. So from the R1 to the R5, that is what the control card looks like, or the control unit, and that is for the bigger drive. And there you'll see that the terminals are color coded. For instance, all your inputs, your analog inputs will basically have a green terminal. Where you look at the digital inputs, it's a yellow terminal. So they basically color coded it just to make it a bit easier. Then looking at the front here, that is of course where your graphical display will be plugged into. When you lift this cover off, there is a place as well where you can actually, where it's got a slot to add in things like your Profibus card or your Ethernet card, etc. Here you've also got another slot, which is, okay, sorry, there it is. That's actually for your field bus. Okay, and that one over there, your option slot C, is for your, if you want an extra relays or you want extra IOs, there are different cards that you can basically plug in to actually allow you to have more inputs and outputs and relays. All right, and connectivity. Okay, we basically comply to a lot of different communication protocols. Below are some examples: Profinet, Profibus, Modbus, Ethernet, DeviceNet, CAN, Open. There's a lot of ones that we basically support. So what you could basically do is, if you're not too sure and you need to, let's say, buy a couple of drives to maybe keep a stock, etc., you guys could basically buy the drives without any communication protocol. You can buy the drives as is, and then if you see, okay, now you've got an inquiry for these drives, and now you need Profibus cards, you can always order the Profibus cards afterwards, and then you can add it, plug it into the drive, or you can keep those cards as well on the shelf as you need them. And then Sean last week, he basically mentioned more. He touched on this ability condition monitoring for drives. There are different ways of condition monitoring options. There's a FINA 21, which is, or no, it's the, we'll send you more information on that, but there are different ways of tracking the status of the drive. The one system that we basically did is we actually just used the normal ABB HMI. We used the ADSL router. Then an address was set up with that, and we had one of our engineers say, I could actually control, I could start and stop the drive from my mobile, wherever I am. If the drive trips, we would be able to see what the drive is tripped on, and we could reset it. So that is an extra engineered solution. It is available, but yeah, we'll, I think we'll also add more information onto the webinar as well on this, so that you guys can have a look. All right, and more about the IO cards. These are the IO cards that are available for the ACQ580. For instance, if you want 2 additional relay outputs, by standard, the drive's already got 3. But if you want an extra 2, then you can basically order the CMOD 01 card. You can plug it into the drive, and that will basically allow you to have 2 additional relay outputs and also 1 digital output. And the nice thing about this card as well, it's also got the 24-volt DC. Basically, I would prefer, if you've got anything to do with communication, if it's a Profibus card or Ethernet or anything like that, that you try and include that card. Because when it comes to, or even the CMOD 02 card, most of the cards have got it, but the reason being is I basically went to one of the sites and the 380 volts hadn't been pulled through. We needed to set up the Profibus. So what we did is, because we had external 24-volt cards, we took our own little power supply and we were able to basically set up the drives. You know, the Profibus, the node address, the you know, all that kind of stuff we could do. Also, if you're, let's say for instance, in the plant, your 380 volts falls away, you will have a separate 24 volts. That will keep your communication live, so that you don't have any trip on your field bus. So those are different options and that you can actually look at. Okay, then the keypad. We have a keypad, a Bluetooth keypad. It's the J429. The standard keypads that you basically get is the J400, which is not the Bluetooth. The only difference is, yeah, the J429, it'll basically say Bluetooth, and it'll allow you to connect to the drive using your mobile device. So whether you've got an iPhone or you have a Samsung, you'll be able to communicate. You'll be able to set up the drive, and you'll also be able to make backups of the program onto your mobile. It does take long. I have tested it before, but it is possible. You are then basically able to make any changes to the drive, And yeah, as I said, you can also make backups. So that is quite a nice handy tool to have. And the maximum distance is about 75 meters. So you can stand 75 meters away from the drive, and you can start and stop the drive. You can also change, for instance, your acceleration, deceleration, your maximum speed, minimum speed, all those parameters that you usually would be able to change on the keypad, and also on Drive Composer Pro and Drive Composer. So yeah, if you look at it, you've got your off and hand and off button. Hands would of course be if you're controlling the drive by hand on. If you basically use this button to increase the speed, you can start and stop the drive using the keypad. Auto would be if it's looking at the external reference. So if it's, for instance, looking at the signal coming from the PLC, you can switch in between the two. And you've also got the question mark button here as well. So if, for instance, the drive is tripped, when you click onto that question mark, it'll give you a list of the trips. And if you want to find out more about it as well, then it'll maybe give you a kind of an idea of what to look for. For instance, if the drive is tripping on, let's say, overcurrent, then we know that the acceleration is too short. So we'd have to increase acceleration. The same with if a drive is tripping on over potential, for example. We're stopping the drive too quickly. All right, and also if you hold down this question mark on the Bluetooth keypad, what it's going to do is it's going to pop up with a code, very similar to when you latch your mobile to your car kit. It'll ask for a code, then you can actually just latch your mobile device with your keypad, and then you can make changes and start and stop the drive, etc. So that's that. All right, and then the language packages. When you order the drive, you can also order it with language package. For instance, by standard, if you order it, it will be in English. But if you want the language to be, let's say, in French or whatever, then you could also, offer that as an extra. And also, we mustn't forget as well with the manuals. You can also order the manuals as well, the hard copy manuals. So if you do want manuals, then you always need to make sure that you do mention it. It's not always necessary. I mean, if you have 20 drives, you don't need to order 20 manuals. You can maybe order 2 manuals, for instance. But those are also something that you need to keep in mind.
Vince, I believe you can download those manuals directly from the remote panel, and it gets sent to your email.
From the remote panel?
Yeah.
Look, I haven't tried it myself. I usually download the manuals from ABB Drive Library, or we've got a lot of different platforms that we can go into. We can even go into the ABB Drive, the ABB website, and we can download the catalogs, manuals, etc. But for me, the quickest thing is an ABB Drive Library. The reason being is because I can download it if I'm sitting in front of one of my colleagues or customer, etc. I can actually quickly download it, and I can forward it from my phone directly onto my colleague's email, and he'll get it there straight away. So that's why I prefer the ABB Drive Library. It's very, very quick. You can download what we call the firmware manual, which is the programming manual, and then you can also download the hardware manual. So you've got the hardware manual, which is all to do with if you want to see what kind of cables you need to use, what kind of fuses you need to use, etc. With the installation, you can find that there. Or if you want to look at the physical dimensions, and the firmware would be, just looking at the programming side of the drive. So there are different ways of getting the manuals. So I think these days it's more of, I think the hard copies is basically slowly but surely deteriorating. I think everything is more digital now. It's more like the MacBooks. I don't know who carries a MacBook around anymore. Now it's a case of getting Waze onto your phone, or even, having your Garmin on your dashboard. So I think slowly but surely everything's going digital. It's just much easier that way. So yeah, that's everything on my side. Thank you again for your guys' time. Next, it's going to be James, and he's going to be just discussing the pump features, in terms of the programming features.
Thanks very much, Vincent.
Should I stop
James, over
sharing?
to you.
Yeah, definitely. It's easier for me to just request control and just use your presentation.
Okay, 100%. Sorry, let me just go back. Great. All right, James, you've got control.
Over to you, James. I'm going to let you introduce yourself. I think everyone knows who you are at the moment, but go ahead.
Yeah, well, James Chalmers. I'm the global water manager for ABB Motion. I guess one of the benefits, and talking about the different industry managers within ABB, water is one of those industries where the knowledge tends to be stuck in that company. If we compared it to food and beverage, where you've got large global companies like Nestle, for example, where they intershare. Whereas I don't know how often Brisbane Water is talking to Thames Water in the UK. So what tends to happen is also the employees, once they've worked for a water company, unless they want to move cities to go and work for another water company, they tend to move out of the industry or they're moving into it. So one of the benefits of having the ability to share globally what we've learned is phenomenal. And often that's my role, is to come through and share different case studies. And over the past number of weeks, we've been doing a number of these talking water topics, and the idea of these slides now following are just a recap on what we've covered over the past weeks, and really running through some of the built-in water features, such as the pump clean, and really highlighting the use of these and how they were designed specifically for the industry and for the customers. I think one of the special ones for me is the sensorless flow calculation. I didn't mention it on a case study, and often people will come to me and say that ABB is the market leader in flow products, flow meters on a global basis. And what I try and highlight is, although the flow meter or the flow calculation built into the drive is a calculation, it's not there to replace the flow meter. The tolerances in it mean that you couldn't use it for any kind of metering purposes, but you can use it for early indications. And certainly with the increase across the world of people wanting to monitor the flow of wastewater, where in some cases the addition of a flow meter wouldn't really be a relevant solution to that. This does provide some first level kind of flow calculations you can do to ensure that you can prep other stations, or if you're pumping from one wet well to another, you can prepare another for it. So what I wanted to do on these slides that follow is run through some of the case studies that we did cover. The first one, if you can see the screen there, covers what we talked about, and what we tried to do is link these features in the drive back to actual real life case studies and problems. And one of the biggest problems I find in speaking to water companies on a global basis is leakage, and them trying to reduce the amount of leakage. And I always compare a water company to maybe a chocolate bar company who produces maybe 10 chocolate bars. And if you've got a leakage rate of 40%, if you were a chocolate bar company and you were just throwing 4 of your chocolate bars every hour onto the floor, you may be not in business the next year or next month. And it's the same for a water company. If you imagine they're producing and pumping a lot of water, the energy that they're putting into that water so it can be drunk or used is phenomenal, and any wasted water is a huge loss, especially as the fact that so many millions around the world don't have access to clean drinking water. So what we explained on this case study, if you were on the call, we talked about some of the reasons behind leaks in the network. Not all the reasons, but one of the main reasons is bursts caused by water hammer or pressure transients in your network. So here on the left, you can see a before graph, and this is showing the pressure, and you can see both positive and negatives. So this is every time the pump is started or stopped, or a control valve is opened or shut quickly. And what we demonstrated by putting 2 ACQ drives on the network at the pumps, we were able to calm the network. So actually, what we did as well, we actually reduced the pressure down to what they actually needed, rather than simply over pressurizing it. So yeah, it was a great case study. This is broke down to just two 5.5 kilowatt pumps that we put on some drives. The whole project itself has ended up saving the water company several million now, in not just in energy savings. This is just one of the pump sites, and you can see the energy savings there. The annual savings in maintenance. But one of the things we started to look at was a maintenance cost one of their biggest costs, or was the actual repair of the leaks the bigger cost? And we were showing how we could reduce that quite dramatically, in some cases down to zero bursts. And then this was measured over the 4 years to see the kind of improvement. So that was just one of the ones we covered. Again, all the recordings and slides are available for you to request off Michael or Vincent. The next one we covered was wet wells. One of the other problems we're seeing, and actually, I was about to say funnily, but there's nothing funny about the COVID-19 situation, but certainly in the UK, and I heard it all around the world, was there was a massive demand of people going to the shops and buying up every bit of toilet roll. And suddenly toilet roll was more valuable than dollar notes. And so people were flushing everything but toilet roll down the toilet. And the problems this impacted again on the wastewater companies that are already having problems with the public flushing whatever they want down the toilet. Last week, Mexico City thought they'd discovered a giant rat. It was a 6-foot tall rat that they found in the sewers in Mexico City. After they removed it actually from the wastewater pipes, they found out it was a prop from a movie, Teenage Mutant Ninja Turtles. But it does show you exactly what does get flushed down the toilet. Now, maybe I shouldn't mention that because I don't want to guarantee that our drives can help remove a 6-foot rat from your pipes. But really what we covered on this case study was about the wet wells. So for those that aren't in the wastewater side of the business, when you flush the toilet, often there'll be a series of wet wells or lift stations that then pump onwards and where they can via gravity to the wastewater plant where it can be treated. But it tends to be at these wet wells that you'll get blockages. And what we demonstrated in this case study was the reduction in blocks by using the pump clean function within the drive. That in this case, actually, we had it set up on 3 triggers. Firstly, we were monitoring the torque of the pump through the motor and back through to the drive. And as soon as the torque increased, we ran a forward and reverse program. In this particular application, I was involved in it in Australia, and it was an aggressive forward and reverse program. We also, because of the increase in fats, oils, and greases, we also ran it at every start, which meant that it could break almost a cake layer of fog that had formed. So we ran a forward and reverse at every start. We had it on a trigger for torque, and also we had it on a timed trigger as well. So about half the time that it normally took to empty the wet well, we'd run a forward and reverse as well. And actually, although the illustration might not be the best from me there, you can see what we were trying to demonstrate is actually during the period of the test period, how the flow increased in the pipes. And actually this meant that you could actually pump it for a lot less because it was a lot more efficient because it didn't have the blockages in the pipe. And again, there were massive savings in the maintenance cost. This particular site, when I was there when a breakdown happened. And at the lunch break, I was chatting to the crane driver, and he was explaining with absolute glee the kind of money he made every time he rented out his crane. And in fact, actually, he started charging as soon as the crane left the depot. And other additional costs. This particular water company in Australia insisted on a minimum of 2 workers whenever they were using a crane or working in confined spaces. So again, additional cost just to remove it from the ground. And what we found is as soon as we put the pump clean into it, the reduction in call outs was hugely reduced down to no call outs. On a side point actually with this one, and I like this one because it almost hints at me being slightly clever, but those who know me will know that's not the case. But one of the incidences we had, the non-return valve on this particular one had a chatter point at about 46 hertz, and what we could do with the ACQ drive was enable a skip frequency, which meant that the non-return valve didn't come down to a massive slam, and we could control and smooth that process. And actually this ended up causing saving them over £200,000 in noise baffling that they were going to do as the next project once they sorted out the blockages. So again, a great case study and a real example of working with the partners who are drives people, so that they fully know the capabilities of the drive. And when you're there with a wastewater guy, as a combination, understanding what you can achieve and the functions within the drive can achieve some really great results. For so many years, I've gone around and told people that just simply installing drives doesn't provide energy savings. They've got to be set up and commissioned correctly. And when we put in some amazing features into the drive, it's really worth utilizing them. So if I go on to the next one again was on wastewater, and I touched on the topic of aeration. In this particular case study that I showed, I used a surface aerator or a mechanical aerator. And again, what I was trying to show here, these are dissolved oxygen levels. And for those of you who understand the aeration process, apologies, but for those who don't, the idea is to oxygenate the water. So the more oxygen you can put into it, there's microorganisms that live in there and they require oxygen to live. So very much like a fish tank, for example. You know, you need to keep the fish alive. You keep a correct oxygen level in the water. In this particular case, over the years, the mechanical aerators may have been controlled on the level of the water, but over the years, less and less operators are working on the sites, and so this has meant that the mechanical way of changing the level of oxygen has not been done, and in most cases it was controlled on and off control with direct online starters. I think I said when I presented this one that this particular application, again, I was involved in it. I had seen some ingenuity from the site where they'd used a broom handle wedged across the corridor and was ensuring that it constantly restarted every time it tripped. So yeah, you can see here there was the on and off control, so getting up to levels of around 6 there, when ultimately you want to be, well, this particular site was in between the 1 and the 2, where you wanted the DO level. If you under oxygenate, obviously the microorganisms die. If you over oxygenate, they can. One of the guys on site referred to they can become lazy. So you know there's no point in putting that extra energy into the water because they're just going to become lazy. And in fact, actually, you can overfeed them, and they become a lot less effective. So what you want is the results here. And this was a case of installing the ACQ drive and simply connecting it to the dissolved oxygen sensor on the side. The first bit here was another story. This was the site actually wanted me to do it all through the SCADA system. I was trying to explain that millions had been spent on the development of our PID system within the drive, and maybe if we directly linked it in, I could get better control. So you can see this happened at lunchtime actually, and while everyone's off, I just took the 4-20 and put it into the drive, and I just wanted to prove the kind of control I got. And you can see there the nice calm. Ultimately, in water and wastewater, the idea is to calm the network. You know, take the pressure transients out for leakage reduction. Here, you know, take off the process ups and downs, so that later on through the wastewater treatment, you can reduce other things like chemical additions, but you can calm the process, and it's a lot easier to control the process then. And again, you can see here, we've put down the energy savings that were achieved on this, and the payback of doing this kind of installation. These actually became, maybe you can hear it in my voice, they became my favorite application doing aeration, and not just in mechanical aeration, rotary or surface, but in blower aeration. And I love the closed loop capabilities, and more recently now, even linking that back to the ammonia, so that we can have different reactions from the drives. But again, a lot of it takes an understanding of the process and getting involved, and you know, this is where, you know, the knowledge of our partners, and certainly the ABB staff on the applications is core to achieving the right goals for buying a drive. And I'll skip through this animation. Probably would have impressed people many years ago, but now I think we've all seen PowerPoint enough times. So yeah, we've got multiple flyers on the drive. We've got multiple hardware manuals explaining in full detail, and PowerPoints, you know, as Vincent presented today. And I really want to promote what Vincent presented after every one of our presentations during the Talking Water series was the use of the new swipe guide tool. And I really, you know, push people to use this swipe guide tool. It's a fantastic way, especially if you're out on site, of very quickly going step by step through each one of the processes. You know, I've got a very fancy Garmin watch, and at the beginning I was worried that I wouldn't know and I wouldn't use all the features, and it would just very quickly become a fancy watch that just tells the time. And this was our worry with the ABB water drive, is that it would be a very fancy drive with all the features, but what good is that if you can't use the features? So this really is a great step-by-step guide showing you exactly all the pressures and options in setting it up so you can get the most out of your drive. That's the end of my bit. I think we've done it just in time then, Michael, just for questions.
Sure. Thank you very much, James.
I'll put the recording off if you want, so we don't have to record.
No, keep it on for the questions.
Okay.
So we do have a couple of questions. Yeah, I think the first one is for you. Do you require a sine wave filter for a borehole pump?
Wow, who was that? That's a really good question. and you know what? When a question like that comes in, you're 100% that the guy asking it knows this. Now, certainly for me, you can go into looking at the length of the cables, and but I've got a bit of a theory on this, that I go in a bit belts and braces. My theory is that if you install one at the beginning and you make it a nice installation, you don't have to go back in and retrofit one, because I think the more times you revisit an application or a job that you've done, I think you're just eradicating any kind of margin you make on it. And most of the times, as technology and pump technology and maybe where the scarcity of water has meant that the wells have become deeper and deeper. Also, sometimes if you're retrofitting it and the different specs on the actual motor, the pump or the motor, yeah. I think a long way of saying it. Yes, I would recommend it. Of course, you can do some clever engineering at the beginning and work out whether you need it or not. But yeah, for me, it depends. You know, how much margin you got in the job and how many repeat visits you want to do from nuisance tripping.
Thank you.
Whoever asked that fully knows the application. You can be sure, because it's a brilliant question for it. And although we can't see their face, yeah, they definitely sat there smiling.
I think the next one is for Vincent. You spoke about the Bluetooth connection and the maximum distance. Is there a requirement for line of sight, or Or do you have to be closer if there's walls and all the rest of it?
Yeah, look, 75 meters is basically if there's no walls or any obstacles in the way. Of course, if you do have a couple of double walls in between, then of course it would affect it. It's really like if you have like your router, at home, your ADSL router, etc., it does affect it. So 75 meters is if there's no obstructions. Yeah, so what I can do, I can actually add some information onto, I'll send it through to you, Mike. There is an article where it actually shows you, but yeah, that all depends on what kind of obstacles you have in between.
Okay, perfect. And then James, I think I'll throw this one at you. Which inputs does the pump drive require to calculate flow?
Okay, so that's so it's a sensorless flow calculation, but it can take inputs from different sensors. We've just released how to use the sensorless flow in a quick flyer. What we're trying to do is produce documentation for every single one. Vincent, you might be able to help me out more on this. I haven't actually done it with any kind of sensor input. I've just done it as a sensorless flow calculation setup.
Yeah, no, look, I know that it is possible that you can eliminate the sensor. Then it actually goes according to the curves that you've sent as well. But yeah, look, I can just send some, Mike, what I'll do, I've got some information on setups, etc., that I'll also include here as well for the
Super.
ACQ.
We can add that to the landing page.
Yes, yeah, we'll.
Yeah. And then Vince, I'm going to throw this one at you. Can you elaborate on the pump cleaning function for the drives?
Yeah, that's basically, look, pump cleaning, what you can do is, with the pump running for a certain amount of time, sometimes you get sediment at the bottom. It might be a rag, etc. as well. And eventually what it'll do is it'll actually clog up the propeller, it'll clog the whole system. Now, what you can do with the pump cleaning, you can actually set it up so that on every startup, it automatically does a pump cleaning for a certain amount of time. So what it basically entails is that the rotor will basically go backwards, forwards for a certain amount of time to remove that obstacle or the dirt at the bottom, and then it'll basically start. So you can either do it on every single startup that it does it automatically, or you can have you can have a digital input for that. So let's say, for instance, digital input 4 you're not using, you can actually make it so that you've got a switch there. So if you make that switch, it'll basically do a pump cleaning for the certain amount of time that you specified.
Thank you. James, I'm going to switch to you. Is there a reason why the low harmonic drives only go up to 110 kilowatts on the ACQ580? And I think that's for the ACQ580-01.
It might have been a better one directed at Vincent there after his presentation, but because I don't believe that's the case. I believe they go all the way up to 355 in the low harmonic with the ACQ at the moment.
And I know last week or the week before you spoke about our IP55 drives, and that are probably more efficient than any of our competitors. Maybe you can elaborate on that a bit.
Okay, yeah. So certainly on the IP55, and I think when I was talking efficiency, I was talking maybe efficiency for spacing. Ultimately, a lot of money is spent on putting drives into panels and then trying to cool the panel. With the benefits of the IP55, you can then you don't need to put it into a panel anymore. And I know certainly in some of the European countries we're seeing a great adoption of that. So yeah, in terms of efficiency, yeah, I guess you'd see efficiency savings on reductions of fans. And well, also the thing is it's such a compact drive at that size. And you see a great footprint saving on any control room as well.
Yeah, no, I agree with you, James. I've actually, in the previous company I was with as well, we did a lot of water projects, and most of the drives that we supplied for the one company was all wall mount drives, IP55s, because it was in a very clean environment. It was in a substation. There weren't any MCC panels. the guys basically had like rails, and we basically hooked those drives onto there. So in terms of if there's a breakdown, etc., it's a lot easier as well. It's easily accessible. You don't have to struggle to get into a panel to try and take out the drive. It's very easy to take the drive off the wall. So, but there again, if we do that, as I said, the maximum is a 250 kilowatt. It's not a very small drive that either, but it is possible. If you go with IP55, you don't have to basically then have it in a panel as such, because it is enclosed. There's not going to be issues where you get dust particles or anything going into the drive and then eventually, you know, affecting your fans, etc. In terms of the boards as well, the boards have been conformally coated, so you don't have to worry about that. That's also with IP21. So it all depends from what the customer's requirements are. But yeah, that is an option. At least you have an option of going with IP21 and 55. And yeah, you just got to weigh it out as well in terms of the kind of environment. If it's a very dusty environment, then IP55 is a way to go, and a very corrosive environment as well.
And is that a trend that you guys are seeing, moving away from the cabinets? I mean, obviously not for the bigger drives.
Look, we are basically seeing that in terms of, look, we are still going a lot with the IP21s. That's basically for the guys that are building their own panels. Then it makes sense to go with the IP21s. But when it comes to some of the plants, project houses, etc., they might go with the IP55 because it's just very easy to install. And then in terms of, as I said, if it goes bigger than a 250 kilowatt, then the guys also, we give them an option of having a 04, a modular unit, or a cabinet unit. Because if you are building your own panels, etc., it doesn't make sense to actually go for a cabinet unit. 04, a modular unit, is perfect for that kind of environment.
Super. We don't have any more questions, but I'm going to open it up to the floor now. You guys have the opportunity to unmute yourselves if you'd like to ask James or Vincent anything before we close. Right, if we don't have any more questions, then I'm going to thank everyone for participating and for joining us. And if you've joined us on any of the other sessions, thank you very much. We do have the recordings available on demand on our web landing page.